Determine the number that makes the statement true. These are using simplified versions of the fractions. So if we were looking at 7 to turn it into 35, we would multiply 7 by 5 to get 35. So to fill in this blank, we need 3 times 5. So that would be 15. In problem 4 here, in order to get from 28 to 7, we would need to divide by 4. 28 divided by 4 gives us 7. And 16 divided by 4 is 4. So go through and use the strategy of either multiplying or dividing to make your fraction or the equivalent fraction have a larger and smaller denominator or numerator, and fill in the blank. Here we see line L, line M, and line N. Which one do you think is the steepest? In the previous lesson, all of our graphs were proportional and they went through the origin. But here you see line L goes through the origin, line M is above the origin, and line N is below the origin. Does that change how steep the line is? Let's examine this a little more closely in the lesson. It says use a slope triangle to find the slope of line L. So we're just going to find 2 points or places where it crosses in the corner of a box, like here, and we're going to create a slope triangle. So a right triangle coming off of that line. Here it went up 1, 2, 3, 4. And then it went over 1, 2, 3, 4, 5, 6. In the last lesson, we talked about the ratio of the height to the base, and we wrote it as a fraction. We also talked about how you take your elevator up to the floor you're staying on, and then you go across the hall to find your room number if you're in a hotel. So the change in the y direction divided by the change in the x direction. Just like in our warm-up, we can reduce this fraction. 2 goes into both 4 and 6, so 2 times 2 and 2 times 3, meaning the slope of this line is 2/3. Here, we're looking for where it crosses in the corners of the boxes. So here's a spot, and here's a spot. This one goes up 2 and over 3. And again, we do the elevator, then we walk over to our room. So the slope of this one is also 2/3, even though it doesn't cross the y-axis in the same spot. Here's a spot, and here's a spot where they cross. So this would be, again, 2 and 3. So the ratio of the height to the base, the slope of this one is also 2/3. So they have the same level of steepness to them. Here it asks which line in problems 1 through 3 is the steepest. They all have the same steepness. And that's because all of their slopes were equal to 2/3. For problems 5 through 8, find the slope of the line. So we're looking for spots where they cross, in the corner. This one appears to have gone up 2 and over 5. So we do the y change divided by the change in the x direction. That fraction can't be reduced, so we'll just leave it as 2/5. It looks like it crosses here and here. So this rises 5 and runs over 1. So that would be 5/1, which can be changed to 5. So we would say the slope is 5 for problem 6. This one goes up 6 and it goes over 6. So 6/6. 6 divided by 6 is 1, so the slope of the line in problem 7 is 1. So this one went up 4 and over 3. So 4/3. That one you can change to a mixed number if you'd prefer. The slope is 1 1/3, but typically we would use the improper fraction version and say that the slope is 4/3. Graph a line that has a slope of 3/5. So you can place a point anywhere on the graph. And then to create a slope that is 3/5, we're going to go up 3 and over 5 and put another point. And then to create the line, we're just going to connect those 2 points using a straight edge, like a ruler. This one says graph a line that passes through the given point and has a slope of 3/5. So we're starting at this point, we'll go up 3 and then over 5. 1, 2, 3, 1, 2, 3, 4, 5. And we can continue doing this just to put additional points. 1, 2, 3, 1, 2, 3, 4, 5. 1, 2, 3, 1, 2, 3, 4, 5. And then we will draw a line connecting all of those points, again using a straight edge, like a ruler. For problems 11 through 14, graph the line that passes through the given point and has the given slope. So we're putting our point at 1, 3. So we'll start at the origin. We're going to go right 1 and up 3 to graph that point. Then for the slope, we need to go up 1 and over 2. Up 1, over 2. Up 1, over 2. For this one, we're starting at the point 9, 8. 9, 8. And we need to go up 4 and over 3. But because there isn't enough room on the graph to continue, we can kind of work backwards. We know that our slope triangle should be a 4 by 3, and 3 should be the part that goes over. So we're going to go 3 and 4, so that we create the slope triangle. That is correct for 4/3. Then we'll connect those. This one's going to start at -5, -2. Then our slope is 5. So this is 5 with an invisible 1 underneath. So we'll go up 5 and over 1. 1, 2, 3, 4, 5. Over 1. This one has an invisible 1 under it as well. We're going to start at the point 0, -6. We're going to go up 1 and over 1, up 1 and over 1. In your book on page 225, we have a bit of a graphic organizer, and we can fill in some descriptions that we have so far. We haven't worked with any lines that are falling yet. All of our lines have been increasing from left to right, like if you were climbing up a mountain. We're just going to fill in the parts that we know so far. So for the description of what is a slope, it's a number that describes the steepness of a line. For a slope of a rising line, the description, it's the value of the height to base ratio of a slope triangle. So then in this specific example, the height was 6 and the base was 3. So we would have 6 over 3, which is equal to 2. So we can say the slope of the line is 2, because the value of 6 divided by 3 comes out to 2. And that's the end of lesson 17. Check back for future lessons and we'll learn more about slopes of different types of lines.